Example number 58, log x squared to base 3 minus log x to base 9 is equals to 3, isn't it? Yes. You can only solve a logarithmic equation if you have the same base. So if this base is 3 and this is 9, it means 9 can be taken to base 3, isn't it? Yes. So that is the first step before we introduce base 3 the other side, isn't it? Yes. We take this to base 3. So that will be what? We'll have log x squared to base 3, then it is minus. Remember, if you have log x to base 9, that is the same as log x over log 9, isn't it? And what is 9? Over log 9. That means it is log x over log 9 is 3 squared, isn't it? So the power is written as the coefficient, isn't it? The power is that? Coefficient. So that is 2 log 3, isn't it? Meaning what do you get? This is 1 over 2, isn't it? So 1 over 2, then log x over log 3 means it is log x to base 3. Meaning log x to base 9 is the same as a half log x to base 3. So you see we now have same base 3, base 3. Yes. Then we go on the other side of the equation, isn't it? Yes. Go on the other side of the equation. The other side of the equation is equal to 3, meaning the other side we introduce log 3 to base 3. Because log of a number to the same base is 1, isn't it? Yes. So if you look at this problem, base 3, base 3, base 3. Now we have base 3 throughout in each and every term, isn't it? Yes. So if we have the same base, we can now solve it. The next thing is to ensure you don't have a coefficient, isn't it? Yes. You don't have a coefficient. So the first term here, there is no coefficient. That is log x squared to base 3. This a half becomes the power, isn't it? Yes. So it is minus log x to power a half. Then to base 3 to be equals to this 3 becomes the power, isn't it? Yes. So that is log 3 cubed to base 3. Is that okay? Yes. So you now use the laws of logarithm to ensure you have one term on either side of the equation, isn't it? Yes. You must have one term on the other side of the equation. So if you factorize out log to base 3 on this side of the equation, what do you leave with? Here we have x squared, here we have x per half, isn't it? Yes. So x squared subtraction sign goes to division. Divide by x raised to power half, isn't it? Yes. Then on the other side we have log to base 3, then 3 raised to power 3 is the same as 27. So we can now ignore the logs on either side of the equation. So you ignore the log. You don't say divide by log to base 3. No, you just ignore the log. It is like you introduce the log on both sides, isn't it? Yes. So what is x here? Most of indices, when you have the same base with divisions, you subtract the powers. Yes. So this is 2 minus a half, isn't it? Yes. 2 minus a half, you remain with 3 over 2. Lots of indices, isn't it? Yes. Then on the other side, we have 27. So it means, what is x? For you to get x, you multiply by the reciprocal of this power, isn't it? Yes. Yeah, even this 27, I can see if you leave it the other way, no, this is 3 over 2, the reciprocal is 2 over 3. You multiply both sides by 2 over 3. Are you seeing? Yes. So, even this 27, if you left it as 3 cube, would have given you easy time. If you leave it as 3 cube, this power is going to cancel with that, isn't it? Yes. So that will remain with 3 squared, isn't it? But 3 over 2 goes with 2 over 3, you remain with this side is x. Then here you remain with 3 squared, isn't it? 3 squared, which is 9. Or you have 27 raised to power 2 over 3, which will you still get 9, isn't it? So that is the procedure of solving that given problem. You only apply a methodology which will ensure you have the same base all through, isn't it? Yes. Good.